again. So if you aren't here, I am going to be recording our classes and then uploading them to D2L. All right, so I did that for last class. So if you go to the content tab in our D2L course, you're going to see there's a class videos folder on the left-hand side. So you see I'll label it the day and then the actual date of the class. So if you click that, it just opens up. I just upload them to YouTube, so you could just watch you're still going to be responsible for watching class if you're not here. One other thing I'll point out, just because it's right here, is I also have a video about how to make a submittable PDF. There are some iPhone or Android apps that if you take pictures of your work, it'll automatically make them into a PDF. Or you could do the method that I showed you in this video. Only because after this homework, I know some people submitted pictures, and if it's one picture and it's all of the work, that's fine, but you're going to see with future homework assignments that it's probably going to take more than one picture, and I only want you to submit one file, okay? So if you're really not sure how to use an app to make the single PDF, go ahead and watch that video. And then the other link here is instructions on how to do it on an iPhone. If you have an iPhone, everyone has the Notes application, and that has the ability to do it. Okay, so this is where I'll store the class videos. And also, I was going to share the class notes sort of every week and post them on here, but it's an easier way. I just have one link, and when you click this, it'll just take you, I don't know how live it is, right? Because I have my notes page open here, but this is also that same notebook, just an online version. So you can always access my notes at any time, all right, through that D2L site. All right, one last thing in D2L. If you remember, the grading policy for homework is if it's satisfactory, right, you get +2 points, and then it could go anywhere from +2 to -2 points if you just don't hand it in at all. How you're going to see those grades, because I want to try to limit the amount of paper that we exchange with each other. When you go to your grades link in D2L, you're going to see, grades for the course. On the very bottom, you're going to start seeing these things that says homework number 1 for exam 1. Now, the for exam 1 just means that those points earned from that homework are going to apply for exam 1. Now, it's just going to be text here. So this isn't going to be used or calculated in any of the other grades. I'm going to manually add in your points to the exam 1, but this is just so you have a record of what I graded each homework on, all right? And I'm not going to collect the homework every time, all right? I try to do about 3 homework collections for each exam, okay? Is that all making sense? Great. Okay, so let's go back to my notes page. All right, so we started Section P.3, but I want to go back to Section P.2 briefly. And here was the homework assignment. Does anyone have any questions about that homework? So what I do is when there's a homework assignment, I'll spend a few minutes at the beginning of class answering any questions you might have about certain problems. I'll even go over just a couple of them, but we won't spend too much time. So does anyone have any questions about any of those homework problems? And again, just yell at me if I can't see over there. Any questions about that homework? No? All right, there were 2 people who came in. What's your name? I just want to make sure I get your mark down. Liam Mead. And then I saw somebody else come in maybe over there. Yeah. Constantinos. All right. And Federico didn't come in? All right. So no questions about Section P2? We're good? All right, I'm going to put that section to bed. So we're good with that one. And we'll go right back into Section P3. So we didn't do much in this section just yet. So this section's on polynomials, so I'll kind of just review some of the definitional stuff we have at the beginning just to make sure everyone's on the same page. So we define something called a monomial, and this is just a polynomial with one term. So I gave you an example, something like 5x squared, and it looks like this. There's some coefficient in front of a variable term, so just call that a, and that's going to be a real number. And the variable can be raised to a certain integer value. And we call whatever integer value that is the degree of the polynomial. So if this was k was equal to 2, like in my example of 5x squared, we would say that's a second degree polynomial. And sometimes certain degree polynomials have nicknames, right? So we call a second degree polynomial a quadratic, right? So when you take two monomials and then of the same degree and combine them, so in this case we have 3x squared plus 5x squared, right? That would be a binomial if we're adding two monomials together. You can combine them if the degree of the monomials are the same. So these are both quadratics, right? Second degree polynomials. So you could combine those and you just add the coefficients in front of the variables. Okay, so I just gave you an example over here, 2y squared plus 3y to the fifth. Can't add those together, okay? Can't add them. Okay, so then just general definition of polynomials of one variable. Again, it's the sum of any number of monomials. So I gave you a couple examples here. These are quadratics. For the most part, quadratic polynomials are going to be the ones that we'll deal with for the most part, okay? And I know at some point in your high school careers, you would have seen quadratics before. Okay, so hopefully this is still a little bit of a review. So all I showed you here was sometimes we'd like to label the coefficients of a quadratic like this. So we usually label those coefficients A, B, and C. So I'll even add here that the general form of a quadratic is ax squared plus bx plus c. So the x squared term has a coefficient. We just generally, math books tend to use a as that variable. B is the variable next to the first degree variable of x. And then the coefficient all by itself on the end with no x is going to be c. So it's good to pick those out. So in this first one, 6x squared plus 2x plus 1, we have 6 in front of the x squared, so that's a, and then b is 2 and c is negative 1. Or I'm sorry, positive 1. And then in the other example, I kind of just rewrote this 5x squared minus 5x minus 6 quadratic. Just show you how to pick out the a, b, and c variables, because a, b, and c will take on the negative signs that are in front of each term in the polynomial. All right? Good review of polynomials. And this was the only thing I did that day. I showed you an example of adding two polynomials together. Okay, so they're pretty simple. So you're going to see these each have 4 terms, but the highest degree is a degree 4 monomial in each of these polynomials. So if that's true, they could have a maximum of 5 terms, right? Because you'd have the x to the fourth, the x to the third, x squared, x, and then the thing at the end is just a coefficient. So they only have 4, it just means they're missing 1. So I showed you, what's the most efficient way of adding them? Well, you could probably just figure it out by looking over here and say 3x to the fourth plus 5x to the fourth. That's clearly 8x to the fourth. Or I showed you a method where you're literally putting the polynomials on top of one another. And then anywhere you're missing one of the degreed monomials, like let's just say in this first one, I'm missing a term for x, right? You see in this 3x to the fourth first one, I don't have an x. So I put in a plus 0x, okay? Just as a placeholder. And then I did the same thing for the second polynomial. And I'm adding them, so I just put them on top of each other, lining up the degrees, right? So all the x to the fourths are lined up, x to the thirds, and so on. And then I just added them. And then we get our final answer, okay? So I mentioned, maybe I did. I'm not sure if I did, to be honest with you. On quizzes and exams, I definitely did. On quizzes and exams, I'm going to want to see as much work as possible, right? Did I mention I like to give partial credit? I did mention that. Okay, good. So here's the thing. If you just had these, so these two maybe would be given to you on a quiz or an exam. And if you just write out the answer and there's terms that are wrong, I don't know your thought process because I don't see any work. So the best thing would be to give me as much work as possible. So even if this is maybe tedious for you because you know how to do this already, if you do make a mistake, because everyone makes numerical mistakes, you see me do it all the time. And by the way, if I do make a numerical mistake up here, please just say, hey, you did that wrong. Could you check that again? And that's no problem at all. I'd rather have my notes be correct than incorrect. So I know everyone makes mistakes. So if I can pinpoint that mistake, I'll take less points off on that problem. Okay? All right. So that's adding polynomials. Okay. I'm just going to change colors simply so that you could see kind of where we the new material starts for today. So I'm don't know why I'm not very good at this, but I always forget to throw in, dates in the notes so you know kind of where one class ended and the other began. So we're 8/25/20. The next thing we're going to talk about is subtracting polynomials. Now, I originally grew up in Scranton, and I talk really fast. Did anyone who's from this area? Are there a lot of local people? So all these local people that Northeastern PA has their own dialect, right? So I don't know if you can hear it in me, but we tend to forget T's a lot. Like I say hot dog, right? But if I'm talking it real fast in a sentence, I'll say hot dog, right? We drop T's and we do all kinds of strange things. But we tend to sort of take words and sentences and clump them all together is sort of how I like to describe our accent. So if you think I'm going too fast, just tell me to slow down, okay? And I absolutely will. And I don't take offense to anything like that. All right, so let me give you two polynomials and we'll subtract them. So here's 2. All right, so I'll give you the first one. Sometimes I label things like that. So 2x cubed plus 5x squared plus 2. And then the second polynomial, negative 10x squared plus x minus 2. Okay? And what I'll say is let's subtract 2 from 1. Okay? Just want to get you used to that terminology. So we're going to subtract the second polynomial I'm giving you there from the first. Which means I'm going to do a very similar process to this pink-purple example you see up on the screen, just with subtraction. So the first polynomial I'm going to put there is the one that's labeled number 1. So it's the second one that I mentioned, and subtract 2 from 1, because I'm taking the second one away from 1. So here's the first one. So it's 2x cubed. Now let's see. So we're missing the x term here. So I'm going to put a plus 0x, right? We don't have that term there. And then subtract, and I'm going to write the second polynomial. Now we're missing the x cubed term. So I'll put 0x cubed minus 10x squared plus x minus 2. Right? Now, the thing when you subtract polynomials, it's like the second polynomial has a big parenthesis around it, okay? Now what happens when you have a negative sign next to terms within a set of parentheses? What do you have to do to that with that negative sign? Yeah, you have to distribute it through each term, right? So each term in that second polynomial, the signs just flip. They change, right? All right, so the first one doesn't matter because it's 0x cubed. So it's 2x cubed minus 0x cubed. So my final x cubed term is still 2x cubed. All right, now we're on to the x squared term. So it's 5 minus a negative 10, right? So that negative 10 sign flips to be a positive 10. So we're really doing 5 plus 10. Does that make sense? Right, because those two negative signs become a positive. So that's going to be plus 15x squared. Now for this next one, we have 0 minus a positive x, right? So minus times a positive is a minus. So we have minus x. And then finally, we have a 2 subtracting a minus 2. So when you distribute those two negatives, or that first negative sign to the negative sign on the 2, it's going to become a plus 2. So it's 2 plus 2, we get plus 4. Okay. All right, so they're pretty straightforward. I mean, if you can do one, you could do them all. All right, again, set them up. You're either adding or subtracting them. And again, put the zeros in there for terms that don't exist, and then you just add or subtract vertically. Okay? Yes?
Would that be like subtracting the first? Would that be like 1 minus 2 instead of 2 minus 1?
So subtract 2 from, yeah, so what we just did was, instead of rewriting them all, we did this, right? Okay. So that was 2 from 1. Now, if I said subtract 1 from 2, it would be the opposite case.
Okay.
Does that make sense? Okay, good question. Yeah, so that's why I wrote this here, because I wanted to make sure that you understood that I want you to take 2 from 1. Okay? All right. So that's adding and subtracting, very straightforward. Okay? Everyone's okay with that? Okay, so the next thing, we're kind of just going to go through all the basic mathematical operations for polynomials. Multiplying, oh God, I can't spell. Multiplying, we'll just put polys. So I'll go through a few methods. The first method I'll go through is just distribution. And we actually already did that a little bit in the subtraction one, right? We distributed that negative sign in the second polynomial through each term. But it's not just negative signs that can be distributed. So here's an example. So let's say we had 2x squared, and then we're going to multiply that monomial by a quadratic polynomial. All right, so here's what we're going to do. You're just going to start with there's a single term here. So we're going to want to multiply that first term by the first term in the quadratic. Now, again, this is just showing a lot of work. Eventually, you won't have to do this, right? So we're basically doing this. That's the first thing we're going to do. And then we're going to then multiply the 2x squared by that middle term, negative 10x. So this is how I would write that. Again, a plus 2x squared times negative 10x. So at least doing it that way, you're always doing plus, right? And then the negative sign, is going to be contained within that second set of parentheses. And then finally distribute the plus 2x squared times negative 3. So probably most of you can probably do that in your head, right? Without actually writing that line out, you could see that that's the process, okay? But again, the more work you give me, I could kind of figure out where your errors are. So now you just go ahead and multiply everything out. So we have 2x squared times 5x squared, so that's a 10x to the fourth, right? Because we know when you do x squared times x squared, when you're multiplying, you add the exponents, right? That's a Section P.2 thing. And then we have a negative 20, and then this one will be x cubed, because it's x squared times x. And then the last term will be negative 6 x squared. And that's our final answer. Also, I think this was in P2. Let me check on that. Oh, because it wouldn't have been in P2. Well, I'll say it now. When you're going to give answers, and the answers are in polynomials, you're going to want to have the highest degree first. So in this case, the highest degree was x to the fourth. And then lowest degree last. So you start highest degree, and then you move through to lowest degree. Selfishly, it's the right thing to do, but then also when I'm grading things, if everyone has the same protocol and process, when I go to look at my solution and then your solution, if you have it highest to lowest, right, it's easier for me to go through and check to see if it's correct. Okay, so always highest degree to lowest degree. Okay, so here's another distribution example. This is a more difficult one, just in that there's more terms. So this was a monomial, right? 2x squared times a quadratic, so just a polynomial. So I'll label that just as an example. And then another example would be something like this. So taking a binomial and then multiplying it by quadratic. which is a trinomial, right? 3 terms. So instead of just distributing one term throughout that quadratic, now we just have to distribute 2 terms. So I always like to write this next line like this. So we're going to be doing 3x squared times that entire quadratic now, because we have a plus sign there, right? This first binomial is separated by, or the 2 monomials are separated by a plus sign. That plus sign is what goes in between the next 2 things. So we have that first distribution, and then we're going to do plus 2x, and again, multiplying it by the same quadratic. All right. All right, so we're going to distribute. Now I'm going to take the shortcut now. I'm not going to rewrite everything here. So I'm going to do 3x squared times x squared. That's going to be 3x to the 4th. And then 3x squared times negative 2x is a negative 6x cubed. Right? And then 3x squared plus 5 times plus 5 would be plus 15x squared. All right, so there's the first half of this distributed. Then we just do the same thing for the second half. So it's plus, we have a 2x times x squared, that's 2x cubed. Then 2x times negative 2x, negative 4x squared. And then finally 2x times 5, or plus 10x. And then finally, now we just have to combine like terms. So if you remember from section, or it might be at the beginning here, right? Same thing we did with adding polynomials, right? You could add, where the hell is it? 2 monomials of the same degree can be combined. So let's look at the x to the 4th. There's only one x to the 4th term, so I leave that one alone. But we do have 2 third-degree polynomial terms, or monomial terms. We have negative 6x cubed plus 2x cubed, so that just becomes a negative 4x cubed. We have 2x squared terms, a 15x squared and a minus 4x squared, so that's plus 11x squared. And sometimes I'll even do this. Again, if you're going to do this, please make the strike-throughs not obtrusive so I could see what you're striking through. And this way it helps you account for all the terms to make sure you didn't miss any. And then finally, the only thing that you would see that's left is a plus 10x. And then that one's gone. All right, so that's another little trick just to help you keep track of terms. Okay. So that's distribution. Okay. Sound good? We're okay? Now what I'll do is I'll go through a bunch of examples, because there's a couple other things we have to do for this section. Now, depending on how much time's left, I may go back and do some additional examples, or even ask you, what would you like to see again, just in terms of numbers of examples, okay? And especially if something seems very basic, I won't do more than one. But some of the more complicated things, I may do multiple examples during the notes. Okay, so that's multiplying, or the distribution multiplication process. Okay, so let's go into a topic in this section. They call it special products. And I like to sort of call these ones, they're sort of just, they're the same things we just did. When you're multiplying polynomials, you're essentially always distributing, right? But some of them, there's tricks to actually doing them. And I know you've seen a couple of these before. I don't know what grade it would be, but you can maybe remind me. So here's an example. I know you've all seen how to do something like this. Right? What did you use? Use some mnemonic. What is it? Foil, right? By the way, I hate little math tricks like this, right? Who took trigonometry in high school? remember SOHCAHTOA? My mortal enemy. I hate that. Just, I know it helps people, but like to me, it's like, just remember it, dude. There's only 3 triangles. Just remember it. But anyway, if it helps you, that's fine. So I'm going to show you how to do it in case you don't remember or you need a refresher. But I don't know. For some reason, it irks me. Okay, so we're going to do foil. Here, I'm going to I'm going to get a little fancy with the colors because it'll be easier. I'm going to make each of these a different color here. Some people work better with colors. All right, foil. Let's go back to blue, if I can find it. All right, the F means first, right? So the foil is telling you which terms in the product you multiply together, right? So first means these guys right here, the ones that I'm labeling in blue, right? So that's just x times x. Okay, so there's your first. That's x squared. Now I'm going to go to green. O means outer, which would be the 3 and the 5. Now be careful here with the signs, right? So that's a plus 3 times a negative 5. So that's going to give me a negative 15. Now the order in which you do these doesn't matter, but it just foil it's a nice word, I guess. So people use it. Now I means inner. So the inner ones would be the 3 and the x, like that. So that's going to be a plus 3x. And then finally the orange, last terms. So that's going to be the 3, I made a mistake. What did I do? Yeah, I did. That's all right. So we'll make this, change this to green. Okay, maybe I should do foil more so I don't make mistakes. So the outer is here. I'll put it on the bottom. It's this guy right here. My bad. X times negative 5, so that's negative 5x. And then finally, now that I've seen my mistake, we have the 3 times 5, which is negative 15. All right. All right, there we go. Now the only thing left to do is combine like terms like always, and it'll just be x squared. Let's see, negative 5x plus 3x is negative 2x minus 15. That's it. So that's foil. All right, let's try another one. I could probably get rid of all those colors. There we go. Here's another one. Now inside these monomials, because for foil you have to have 2 binomials, right? That's the special case. That's why these are special products. Let's take 5x minus 6 and multiply it by 2x squared plus 5. All right, so you see that that second binomial has a x squared term, and the first one doesn't, but that's okay. We're multiplying, so it doesn't matter. So again, let's use FOIL. We're going to do the first terms. So 5x times 2x squared is going to give me a 10x cubed. Then we're going to do outer. So 5x times positive 5 plus 25x. And then do inner, which is negative 6 times 2x squared minus 12x squared. And then finally negative 6 times positive 5 minus 30. Now that's fine if you don't want to put them in order, if you think you did it right, but just because I told you to do the highest order to the lowest order, I would rewrite this like this. Okay. Okay. So hopefully FOIL, just a little review. Okay. Now I do want to show you one thing with this first one. So I'm just going to come down here. Let's say you don't remember FOIL and you screw that up, or this could even be a nice check to see if you're doing it right. Let's solve this first problem just like we did any of these up here, the distribution, because every one of these you can do with distribution. They just take a little longer. So let's say it's some extra time on a quiz or an exam, and you just want to check this. So remember, this is what we did. We took the first term in the first binomial, so this is this x over here. So we do x times, we're going to times it by the entire second binomial, and then add to it this second term. Now I know to add to it because it's positive 3, plus 3 times x minus 5. Now this is much easier now because you don't even have to think about FOIL at this point, because now you just distribute each of these x and 3's. So you have x squared minus 5x, and then plus 3x minus 15. Now you see that you're going to get the same second line, right, when we FOILed. And then your final answer is going to be the same. All right. Now which one's easier? I don't know. If you remember the FOIL thing, again, FOIL's there for you to just quickly do these, right? Because you want to just try to, be efficient when you're solving these problems. Okay? Awesome. Okay, so let's talk about some other special, and I can go back and do more FOIL if you need to. So another special case or special product would be squaring a binomial sum or difference. Okay. All right, first things first. If you had something that looks like this, so let's say you saw that and then we want to simplify it. All right, so there's a way to do this. I'm not even going to show you the way the book does, just because I think there's just a much easier way. If you see this, isn't that the same thing as x plus 5 times x plus 5, right? Right? If you have x squared, that's just x times x. Now, instead of being a single variable, the x plus 5 term is the variable, okay? So if I'm trying to make it so there's less processes and things for you to remember. In this case, if you see a binomial that's squared, just rewrite it like a FOIL problem and then do it, and then do a FOIL. So we're going to have x squared. The outer term is plus 5x, inner term is plus 5x, and then the last terms are 25. Now what you'll see in this case is the middle terms here, this plus 5x and plus 5x will be the same, and you'll just add those together. All right, they wanted to show you like this. They were like, oh, well, if you have something that looks like a plus b squared, well, here's the formula for that. A squared plus 2ab plus b squared. Nah, don't worry about it. Just do FOIL, right? It's the same thing, all right? For a difference, let's give you, so that's one example. For a difference, same thing. Make it into a FOIL problem. All right, so we'll do it. So 5x times 5x, we get 25x squared. The outer term's negative 15x. So we know the inner terms will be also negative 15x. And then negative 3 times negative 3 is a plus 9. So we get 25x squared minus 30x plus 9. That's it. So those ones really aren't special at all. They're just, whatever. Okay. Any questions there? Okay. Awesome. All right, so at the end of Section P3, there's only one more problem type, and they're really not that different than anything we've done. So they're calling it multiplying polynomials with two variables. You know, so far we've had polynomials of a single variable. Well, a lot of business majors in here, I think, too. You know, when you're talking about, let's say, price elasticity of demand, just throwing something out there. That equation has two variables. So it's just not only, you're only going to see equation with one variable, you're going to see with multiple variables. So all they have you do in this part is something that looks like this. I'll give you a real simple example. So we're going to have x and y as our variables. Now it's no different than any of the, I'll call it arithmetic, right? Multiplication, addition that you did in Section P.2, right? Because if you had something like x times 2y, you knew that was 2xy. So we're just basically using that same idea here. So you can't increase the degree of any of these variables unless you have both variables when you're multiplying. All right, so in the first term, 2x times 5x, there are both x's there. So that's going to be a 10x squared. Then when we do the outer here, it's going to be 2x times 3y. So you could still multiply the coefficients and get plus 6, but then you can't do anything else with the xy's but just leave them, you know, as products next to each other. And then now we'll do the inner. Y times 5x is plus 5xy. And then the last terms will be y times 3y, which will give us plus 3y squared. Okay. Now, let me ask you, are you allowed to combine those two terms? Yeah, you totally are, right? As long as, if you have two variables in a monomial, right, just a single term, and their degrees are the same in both monomials, you could add them. Just as an aside over here, 3xy plus 2xy squared, can you add those? No, you can't, because the y terms have different degrees. So you can't add those. But in this case, xy, yeah, you could treat those as just one variable. So the final answer here would be 10x squared. And if you're writing it how I asked you to write it, highest degree to lowest degree, would be plus 3y squared. Which one of those you put first doesn't matter. And then finally plus 11, right? We're adding here, not multiplying, 11xy. Okay? Is that good? Okay, so that ends Section P3. Would you like me to go back through any other extra problems from that section? Sir? Yeah.
Wouldn't you said earlier you want us to put the variables in order? So shouldn't it be 10x squared plus 11xy plus 3y squared?
I want to do highest degree first.
Okay.
So, well, here's the thing too. X times y, right? That's kind of a degree too, right? They're just from different variables. So just, I would like to see, you can even think about, I want the highest exponents first. Now, if you gave this to me as 10x squared plus 11xy plus 3y squared, I'm not going to mark it wrong. It's still correct, right? The order of, I don't know what that is, commutative property, right? Where you can move stuff around in addition, right? It's completely fine. So whatever you're most comfortable with is fine, okay? Anything else? Now, before I ask you one more time, I am going to tell you, on Thursday, we are going to have our first quiz. Okay? So on Thursday, and this is to people who are going to be watching this video who aren't in class, you're still responsible. Here's the quiz is going to be on Section P2 and P3. So the two sections we've covered up to this point. So if you want to jot that down in a calendar or whatever, wherever you put your information like that. Now let me tell you about my quizzes. you're not. I mean, nothing that we did here was very complicated either. But I don't know if you've noticed, like when I assigned that homework for P2, there were some tougher problems than the ones I solved in class. Like in class, I like to solve, basic to medium difficulty, so you get the concept of what to do, and then you're applying that concept to maybe a more difficult homework problems. And the homework's not all difficult, but some of them are a little trickier. On the quizzes, though, that's not what I try to do. I will never give you more than something that's like a medium difficulty or easier. That's it. I'm only checking the room to see if we have concepts down, right? Because these P chapters, if you don't understand the stuff in the P chapters, when we start getting to the actual sections, like section chapter 1.1, it's going to assume we're pretty much mastered all that stuff in the P chapters. But we never use super complicated stuff from the P chapter. So that's why my quizzes are only going to be checking to make sure that you're understanding. So how it'll work is you're going to come in. I'm giving you a homework assignment for P3. I'm probably not going to collect that one because you have a quiz and I don't want to overburden you with two things right away. So I'm not going to collect the homework. So you do the homework. I'll answer any questions you have on that homework when we come in Thursday, and then just open the floor for any questions for the quiz. Okay? Once that's done, I'm going to do some notes at the beginning of Thursday, and then the quiz will be the last thing we do. Okay? Because I'm hoping, as I'm doing things here in class, that'll just be more of a review to help you do that. And I'll probably give you around 20 minutes to take that quiz on Thursday. Okay? Wonderful. All right, so I'll ask again, anything you want to see from even section P2, from the homework, or anything from section P3 up to this point? We're okay? Okay. All right, so here's the homework. So this is for, let's see, I'm going to give you the page number here. Also, before you leave today, if for whatever reason you don't have the book, feel free to come up and take a picture of the problems. That's completely fine. So this is on page 38 and 39. Okay, so we have, just want to make sure what okay. So 27, 29, and then 31 to 49 odd. 65, 67, 73, and 79. So, I mean, what's that? That's 49, it's 18, 9, 11, 15 problems. So nothing crazy, okay? And again, you're going to see that, and I don't know what your homework habits are, but if you have the notes open on your computer screen, right? The order in which I assign these problems are the order in which I did stuff for this section. So just go back to the notes and you should hopefully see an example, as you're doing some of these problems. Plus, the book itself goes through all different examples. The only thing I'll mention is, sometimes on those squaring a binomial sum or difference, they're going to give you a formula for it, which I think is the wrong way of thinking of it. Just think of it as a special FOIL problem. But yeah, the sections go through and give you extra examples as well, more than I'm giving you here. All right? Awesome. So here we go. And I'll sort of talk about the quiz protocol, how we're going to work with that on Thursday. All right? And I'll talk about how we do makeups, and if, say, you have to be quarantined because your friend tested positive or something for COVID, we're going to have a procedure for that as well. So I'll talk more about the quiz on Thursday. Okay, so let's move right along here. This is great. Let's see, I'm going to go with different color here. Let's go green. So we're going to go to the next section, Section P.4. I wonder if it'll let me. Yeah. Oh, there it is. All right. Okay, so Section P.4. All right, so what we did in P3 was define polynomials and then use distribution, right, to take polynomials that are already factored and then simplify them. So P4 is going to be the reverse process, right? It'll be factoring polynomials that have already been distributed back into factored polynomials. And just so you know, this factoring will not be on the quiz Thursday. All right, so it's only P2, P3. So this is just new material now. All right, so here we go. Factoring polynomials. Okay, so when we do this, we have to find something we're going to find something called the GCF. What does that stand for? Yep, greatest common factor. Because the polynomials we're going to be given are just going to be unfactored multi-term polynomials. So the greatest common factor in the general sense is always going to look like this. There could be a coefficient, we'll call that A. And if we're talking about a polynomial of one variable, we could be factoring out an x term, but that x term could be also raised to some power. So we have, so A, that's the greatest integer that divides each polynomial term. So greatest integer that divides each polynomial term. And then n is the least exponent of x found in every term. Okay. Now this is very wordy, but the actual process is pretty simple, so let's just try it. Very simple one to start. Just a refresher. By the way, when would you have learned this? Is that 8th grade, 9th grade? My son's in algebra now in 9th grade. Did you learn that in 9th grade? Is that? So this is definitely review. All right, but I'm still going to go slow, assuming, you know, it's been, well, that'd be 4 years, right? If you learned it in your freshman year. Some of you maybe learned it in 8th grade. Who knows? All right, so we have 8x squared plus 24x. Okay. So some of you can probably factor this right off the bat. Boom, you're done. But let's just try to find the greatest common factor. All right, so let's find A. So A in this case, greatest integer that divides each polynomial term. So what would that be? The greatest integer that divides each term. Yeah, 8, right? Because 8 divides itself. And then 24 divided by 8 gives you a 3. Now, when you're doing this, you want to make sure that I should probably have put, so 8 is the greatest integer that divides each poly term, and I'm going to say evenly. I'm going to add that at the end, meaning you don't want to have decimals in here, right? So you're only going to factor out integers that divide each term evenly. So of course, 24 divided by 8 gives us an even 3. Okay, so A is 8. And then what's n in this case? So it's the least exponent between the terms. Yeah. You said 1, right? Yeah, it's 1. So if we wanted to write out a greatest common factor, it would be 8x. Now, should I put a 1 here as the exponent? Nah, we just, if you just see x, we assume the exponent is 1. So that's 8x. That's the thing we're going to factor out. All right, so we put that out here in front. And then we're going to have in parentheses the factored binomial. Now, the easiest way to think about it is, all right, what do I have to multiply 8x by to get 8x squared? You help me out with that. Just x. And then whatever the arithmetic sign here, so this is 8, or a plus sign, goes down. And then what do I multiply 8x by to get 24x? Yeah, you get 3. So there's my factored answer. So we just factored that binomial. Okay, let's try another one. That makes sense though, right? This is simple. And again, you'll start coming up with those GCFs in your head. But at first, let's just figure them out. All right, so what's the greatest integer that divides each term? So we'll do that one first. So the least exponent is what? 3, right? Now how about the integer? And typically what we do is we take that first term of the highest degree, so in this case the 9, and then try it, right? 9 divides by 9, so we know that's going to work. And then 18 divides 9, sure, you get an even 2. So A is 9. So we're going to factor out a GCF of 9x cubed. All right, so what do you multiply 9x cubed by to get 9x cubed? A 1. The negative sign comes down. And then how do you get 18x to the 4th with a 9x cubed? You're just going to multiply by a 2x. That's it. All right. All right, one more example, but we're not going to do a binomial. We're going to do this. I'm going to give you something 2x cubed minus 5x squared plus 10x. All right, so you might want to go ahead and think, okay, well, I might have gotten this by foiling 2 binomials, okay? So I'm going to go ahead backwards through this and then I'm going to do reverse FOIL, right? That's the process of figuring out how to go from this back to a product of 2 binomials. But in this case, you're going to first want to look for a GCF, right? You're first going to want to look for a GCF. Now, some of them might not be available, and you'll be able to pick those out frequently the more of these you do. But does this have a GCF? Let's see. What would A be in this case? So this is the greatest integer that divides each term. What do you think? Anybody? Yeah. Oh, so we're talking about integer now. But we're going to the exponent, so that's cool. Let's do that first. So it's not going to be x, it's going to be 1, right? Because it's x to the first power, right? So because there's only x squared, and x, so the least power there is 1. But how about the number, the integer, the coefficient, the thing that comes in front of those terms? Does 2 divide by 5 evenly? It does 10, right? So you're thinking, okay, well, what divides everything evenly? What number? 1, okay? So you can always factor out a 1. Now, what does that do for this? Well, it just makes the thing we're factoring an x, okay? Yes? I'm sorry? Oh, yeah. Yeah, but if anyone ever has to go to the restroom, you don't have to ask. You just go. It's fine. Not a problem. Okay, so I'm factoring out a 1x to the first, so I'm not going to write that. I'm just going to write x. And then we have, all right, how do I get 2x cubed? I'm going to do 2x squared. And then how do I get negative 5x squared with minus 5x? And then finally a plus 10. Okay. Now, the next process, which is going to be the next part of this section, is, all right, well, now you have that trinomial. That's a quadratic. What's the process to factor this? So what's the process, right? Okay. So we're not going to do that one yet just because that's a more complicated one. So here's what we're going to do. The next thing is factoring. So hopefully everyone's good with finding this GCF and just factoring out terms. That's easy. So we're going to factoring polynomials of a certain form, Now we're going to start with a form where the x squared doesn't have a coefficient other than 1. So this will be what it looks like. Okay. So how do we go about factoring those? Okay. All right, so let me just show you what this would look like. Let's say we were going to multiply this. So x plus a times x plus b. So let's go ahead and we'll just see what that looks like. When we FOIL this, we're going to get x squared plus ax plus bx plus a times b. And I could do one more thing here. See these two terms here, the ax and the bx? Can I factor out an x term there? Yeah, right? So I could do something like plus, and I'll put that factored term first, a plus b times x plus a times b. Okay? So here's what we're doing. When you, because this is the form right here, this x squared plus the a plus bx plus a times b. That's the form of the equations that you're going to be seeing. And here's the process, right? So I guess I'm going to sort of make an algorithm for you, right? So what you're going to do is you're going to look for this a, b term, right? Which is really just going to be c in this case because a, right? This term right here is a 1, right? That's a 1. So we don't really have to care about what's going on there, but that's just, so it's going to be 8 times b, where b is that last term, so we're going to have, just looking for c. And then what we want to do, look for an a plus b that make up the product of c. So it's a little wordy, but when you see some of these examples, you'll see it'll be very simple. Okay, so let's do an example, and I'll walk you through these steps. So we'll do a very simple one here. So here's a quadratic trinomial, 3 terms, x squared minus 6x minus 16. Okay. All right, so c in this problem is 16. So we want to try to find a and b. So these, by a and these lowercase a and b's, it's just two integers that when multiplied together give you 16. So give me some examples.
8 and 2.
All right, 8 times 2. What else? 4 times 4. I think there's one more, right? Isn't 16 times 1 also a possibility? Okay. So basically you're factoring the integer 16 or whatever c that number seems to be, all right? All right, so that's your first step, right? So that's process. So look for a times b's that are equivalent to your last term there, your coefficient, c. And then out of those 3 possibilities, which ones can give you 6 when you add or subtract them? Yeah. Yeah, the 4 and 4 won't do it. 16 and 1 won't do it. So 8 and 2 is going to be, and this is process 2, look for A and B that make up the product. So 8 and 2 are going to be involved in our factored polynomial. So now here's what you do. In these cases, where the coefficient next to x squared is always 1, these first 2 terms are always x. Okay. And then the terms that we're missing here are the ones we just found. So 8 and 2. Now, if you remember, the inner product and the outer product always will sum together in these examples. So it's 8x and 2x, but we need to get a negative 6x. So what are the SIGNs, the signs I need to put in here? This is where you just kind of think about it. Let's see. Let's try that. So if this is plus 8 and this is minus 2. Yep, you caught your mistake. That's perfect, right? So minus 8 plus 2. So just think about it. It's minus 8x plus 2x gives you negative 6x, and then you're set. Okay? So that's the process for these types of problems. Again, determine what C is. And again, this is sort of, I don't want to call it new. I mean, when I learned how to do this, we didn't do this. The teachers were just like talking through this, but didn't really give you a process. And I like process because I was an engineer. I was in the physics department, so I like process. So let's try another one. How about this one? X squared minus 3x minus 10. All right, so let's figure out C. So the step one, C is 10. Now, right now, I'm ignoring the sign on 10, right? Because we're going to figure out signs, that's the very last step. All right, so what are my factors of 10? Well, we got 10 and 1, and then 5 and 2, right? They're the only ones. So which one can give you a 3? Should be that second one. All right. So for process 2, we figured out what they're going to be. It's going to be 5 and 2. So we write our 2 sets of parentheses. They're both going to start with X. We put the 5 and 2 here. And to figure out what the signs are going to be, if you see that 10 is negative, you know that you're going to have a negative and a positive, right? You just have to figure out where they're going to go. So where would I put the negative sign? If I want to have a negative 3x. Yep, we're going to have a negative here because it'll be negative 5x, and then plus 2x gives you that negative 3x. Okay. All right, so we're at 9:35. I'm going to give you one more example of pretty much doing the same thing, and then we'll clean up and be ready to go. I already gave you the homework assignment for P3, so we'll be good to go. So there's something called perfect squares. But the process is the same as before. Can you pick these out? Because it makes them a little easier to do. So here's an example. So perfect squares is just the result of doing this same process. So if you have x squared plus 4x plus 4, right? Now I'd like you to start trying to do this without writing out the C's and these processes. What factors of 4 are going to be able to give you a 4 as the middle term? Yeah. 2 and 2, right? So we have an x and an x here. 2 and 2. And since everything's positive up there, you see that you get positive signs in both? So you would want to write the final answer to this as x plus 2 squared. So that's what a perfect square is. And you saw these back over in P3. Just one more. 9x squared minus 6x plus 1. Now this was a little difficult because now we have a 9 out there in the front. But if you can identify it as a perfect square, right? If you could see that, well, these have to be 1, right, to get that last term to be a 1. So the only way I'm going to get 6 in the middle is if I have the factors of 9. Now, what factors of 9 can give you a 6? 3. So you have 3x and 3x. And you'll see that we want a negative 6x. So each of these 3x's has to be negative, and the 1 has to be positive up here. So see that that's also a perfect square. 3x minus 1 squared. Okay. All right, folks. So just before you go, quiz on Thursday again. I'll go over more procedures and everything with that. And it takes a while for the video. If you want to rewatch class, some people like to do that. It takes a while, so it won't be up till probably this afternoon.